Welcome back to the continuing story of Matplotlib. What we did in the last video was look at a basic plot. We worked through that particular program, more or less. Key things to note out of that were that you had to start by importing matplotlib.pyplot as plot. Then you called plot to give yourself a set of axes. Then you called all sorts of methods of the axes object that you got given in order to plot stuff. And at the end, you displayed the plot by calling plot.show. So there's only two calls to the PLT object there to get your axes in the first place and to show it. The rest of the stuff is done by calling methods of the axes object. So the axes object is the key object really in Matplotlib. It's a member of the class A-Axes. So one of the things you'll need to do a lot is know this documentation. Get to know it. Go there right now while you're watching this video. I'll take you there very briefly. So here's the Axes documentation. It's got a table of contents, and the key stuff here is in plotting, where you learn about the basic plots, such as the one we've just seen, axes.plot, but also scatter plots, step plots, bar charts, pie charts, and then there's all the special ones, the not so basic ones like statistical box plots, violin plots, histograms under bind, pseudo color plots, contour plots, and so on. So there's all the different sorts of plots are documented there. And the other place you'll probably want to spend a bit of time is in here under Axes Limits, where you'll learn about setting limits. You've seen some of that already, controlling the labels, titles, legends, scales, aspect ratio, ticks and tick labels, and so on. So this is a really key piece of documentation. Just remember, when you need it, you can Google Matplotlib Axes class. So the word class is probably important in there, otherwise you get a whole lot of other stuff you didn't want. So that's where you're going to spend some of your time. We've looked at some of the key methods there. There's a new one, legend, coming up real soon now that I'll demonstrate to you. So the next thing I'm going to do is move to plotting multiple plots on one set of axes. So here we plotted the sine wave, like so. I'm going to do another plot on the same set of axes. I'm going to plot the cosine of those angles. So that's all I'm going to do, just one more line in that program, and when I plot it now I'll get a different chart. It's not very well labeled. It's still called sine theta, but it has two things on it. A little bit confusing, which is which. If you know which is cos and which is sine, well and good, but maybe you don't. We'd better tell it which is which. We'll do that by giving it a label. So the label is equal to sine theta. I will just adopt the lazy approach now. You can look at the code which does it with LaTeX and puts proper thetas in there. You know how to do that, but I'm just demonstrating stuff. Label equals cos. That is going to be useful only if I generate a legend which tells me what's what. So I'm going to go axes.legend as well. With that change, I should have a graph in which I know which is which. So I see waiting, come on Windows, there we go. So now it's labelled, the sine is the blue one and the cosine is the red one. Maybe I want one of them dotted. I can do that by changing the line style. Line style equals dashed. I won't bother to run that for you right now. You can experiment. So that's two plots on one set of axes. Often though you want multiple plots in a figure. So to do that we move to a somewhat more sophisticated model. We start using the figure object or figure class as well. So instead of asking the plot module for a set of axes, we ask it for a set of subplots and a figure. So instead of calling axes, I call subplots, and I ask how many rows I want and how many columns. So in the example we're doing here, I just want 2 rows and 1 column. And what I get back isn't axes, it's actually a figure. It's a tuple, figure, and the multiple axes, axes array. That means when I plot, I now have more than one axis, so I can call axes of axes array 0 to plot the cosine. That's my first set of axes, and axes array 1 to plot the sine. Oh, sorry, other way around. Axes array 1 to plot the sine. All of these other axes labels here need to be changed as well. Just to make a point, I'm going to kill most of that. You can work through the example here. There's the example which I'm using. If I just run that by itself, I think you'll see what I'm talking about. What I get then is two plots, one above the other. So they're nicely laid out, and of course I have to turn on the grids and everything separately. If you look at this piece of code, what I then do is work through the axes array and set the labels and everything accordingly. I also make use of the figure object I get here to set a subtitle, a supertitle. I'm not again going to work through the details. You can look at that piece of code and hopefully understand it. Key idea though is this line here where I call the subplots method or function in the plot module with the number of rows, the number of columns to get a figure and an array of the different axes available. This makes it possible to plot some quite clever and complicated things in which we share axes, axes labels and so on. You can read about that in the documentation. So the figure class, that's this thing here, is the sort of top level. It represents the whole figure with multiple axes. You don't often deal with it directly except to set the subtitle, the supertitle for the whole figure. You can call explicitly to save the figure, but actually normally you just click the button on it. And you can tweak the subplots in various ways, and you can even do interactive input. Personally, I've never done that. So that's enough for this video. What I'll do in the last video is tell you how you can plot a couple of other graph types, the bar charts and histograms. Thanks for watching. See you in the next one.